Okay, we're going to do the probability examples. I'm hoping I can get through this without anybody waking up. So we have a puppy over here, asleep. And then you can see the baby somehow. Yeah, he's asleep. He doesn't like to lay down. My fault probably, but that's okay. So to do the probability examples here, I didn't do a video for the PowerPoint this time because it's mainly just definitions. There's a few examples, so if you need anything explained, just send me a message. For this though, this is what you'll follow along with on the homework. This will help you more on the homework. So we have the following contingency table, shows the number of people attending a spring music festival. And so this is what a contingency table looks like. An example of one, you've got, in this case, we've got age groups. So these are our age groups. And then you've got whether they're male or female here. And so depending on what you're talking about is what numbers you'll use. The total that attended altogether here is 938. So it says a person who attended the music festival is randomly selected. Find the probability of selecting someone who, and then you've got different parts here, and round your answers to 4 decimal places. So the probability that you get someone that is between the ages of 30 and 39. Then you go up here to your age group, 30 to 39. How many of those are there? There's 146 out of the total that attended altogether, which is 938. So that one is 146 out of 938, and that is 0.1557. So the probability that you would pick somebody, if you just randomly pick a person that's between 30 to 39 that attended this music festival, it would be 146 out of 938, or that 0.1557. The probability that you pick someone that's between the ages of 30 to 39, given that the person is a male. So this is to show you what the given does. So the given changes your denominator. So typically speaking, your denominator will be the total altogether for whatever you're talking about. But if it says given, then that is always your denominator. So you're given that they're a male. How many males are there? So you'd only look in the male column here. There's 496. So that is your denominator. Of those 496, 30 to 39 is the age group we're looking at, so 64 are 30 to 39. So to pick somebody that you know is male, because that's you're picking out of the male column, that the probability that you pick somebody that's male in the 30 to 39 age group is 0.1290 when you divide. So always remember, anytime you see given, that's your denominator. So between the ages of 30 to 39, given that they're a female. So again, you have the word given. So now you're only focusing on the female column. So there's 442 of those total. And how many of those are 30 to 39? There's 82. So divide and you get 0.1855. So keep in mind, generally speaking, like I said, you'll use the total altogether unless it says given, and then whatever's after given is your denominator always. Is between the ages of 20 to 29 or 30 to 39. So anytime you see the word or, that means you're going to add and subtract. The PowerPoint breaks it down into two different cases. One where you don't have to worry about the subtraction, but I generally just say always add and subtract, so then you don't forget to subtract. If you always add and subtract, you'll always add and subtract. You'll never forget it. So for an or, you're going to add. So we're going to add these two together. So between the ages of 20 to 29, you go up here and look. You have 334 out of the total 938. Plus 30 to 39, 146 out of the total 938. Because this one doesn't say given, so you just use your regular 938 denominator, minus what they have in common, Well, in this case, you cannot be both between 20 and 29 and 30 to 39. So you're going to subtract off 0, which is fine. You're just subtracting 0. But like I said, if you always remember add and subtract, you won't forget. So if you add these together and divide and get your decimal, you should get 0.5117. So just remember, if you see or, add and subtract. And the reason you're subtracting 0 here is because those two are mutually exclusive, so it means they have nothing in common. So like I said, you can't be both between 20 and 29 or and between 30 and 39 at the same time. You have to be one or the other. So the PowerPoint talks about mutually exclusive, which means that the probability of both is 0, which is why you subtracted off 0. So the next one you have is between the ages of 40 to 49, given that they're a female. So again, here's the word given, so there's your denominator. We're looking in the female column only, so 442. Between 40 to 49 in that group is 35. So if you do 35 divided by 442, you get 0.0792. For the next one, you have between the ages of 10 to 19, or is a male, and it says think about this one. That's because, like this one, you add and subtract. So add these. So 10 to 19, go up here. You've got 355 out of your total 938, plus a male. You've got 496 of those out of the 938. Minus, this time you can be both. You can be a male between 10 and 19. So you're going to subtract off how many those are, because if you don't subtract them off, they're actually counted 2 times. So this is the 10 to 19 group, and 210 of those are males. So this is the 10 to 19, this is the males, so they're counted twice. So that's why you have to subtract off. So we're going to subtract off how the probability that you're both. So how many between 10 and 19 are male? 210. So subtract off 210 out of the total 938, and if you do that, you should get 0.6834. So like I said, you have to remember to subtract, because otherwise when you do the or, otherwise it gets counted twice. Between the ages of 20 to 29, and is a female. Generally, when you see and, you're going to multiply, except on a contingency table. Because on a contingency table, it gives you the answer, basically. So most time you see and, you think multiply. On the contingency table, you just write down what it is. So if you're between 20 and 29 and a female, how many are those? 180. So it gives you the answer. That's how many are female between 20 and 29. So you just do 180 out of 938. So like I said, generally with and, multiply except on contingency tables. So it should be 0.1919. Is a male, given that the person is between the ages of 40 to 49. So again, if you see given, that's your denominator. So between 40 and 49, there's 103 of those. The males that are between 40 to 49 are 68. So the probability that you pick one is 68 out of 103, which is 0.6602. So that is your contingency table example. So just make sure on those that the given, you change your denominator from the total, or always add and subtract, and then just remember and generally multiply except on the tables. They give you the answer. So the next two deal with well, the third one asks about a permutation or combination, and then the second one here is like how many different codes are available if you have 5 digits. And so if you have 5 digits, that's already 0 through 9, which is 10 numbers total. So 10 total numbers. And so what I usually do on this is I'm going to draw blanks. So anytime you're finding it tells you what to do here about what the rules for each one, and you can assume they repeat. How many codes are available? So you're always going to multiply these. So you're going to have, if there was no rules and it could just be 0 through 9 on any of them, you'd have 10 numbers that could possibly go here, 10 that could go here, 10 that could go here, 10 that could go here, and 10 that could go here. Multiply all those together, that's how many different codes you have. So keep in mind, you're not coming up with the code, you're just trying to figure out how many different combinations are possible based off whatever rules you have to follow. So the first digit cannot be a 7 or an 8. So if you cannot use a 7 or 8 to start with, you had 10 numbers total, that you 0 through 9. If you take away 7 and 8, then you only have 8 numbers left. So 8 possible numbers to go in the first slot. Then it says the third digit, so it doesn't say anything about the second digit. So the second digit can be anything 0 through 9. So there's 10 numbers that can go in the second slot because you can use any of them. So the third digit cannot be a 2. So if you're using 0 through 9, you take away a 2, you're going to have 9 possible numbers that you can stick there. You can do 0, 1, not 2, so 0, 1, 3, 4, 5, 6, 7, 8, 9. And then the last digit, so it doesn't say anything about the fourth one, so again, you assume it can be anything. And like I said, these can all repeat, so it doesn't matter. You don't have to take one away or nothing. If it says they cannot repeat, then like if you put, if they can't repeat, you do 10 in the first slot, then you've used one number, so that only leaves you with 9 in the second slot, and you've used 2 numbers now, so you got 8 in the third slot, and so on. But anyways, these can repeat. So the last digit must be odd. So the odd numbers between 0 and 9 are 0, 2, 4, 6, and 8. So there's 5 of them. So 8 times 10 times 9 times 10 times 5 gives you 36,000. So there's 36,000 different codes that you could make following these rules for that parking garage. So number 3, decide if the following is a permutation or combination and then solve. So based off the PowerPoint, if you look through it, permutations where order matters, combinations where order does not matter. So you've got in a high school cross-country race consisting of 28 participants. Places of first, second, and third will be recorded. How many different ways can the places be recorded? So there's 2 ways to do this one, actually. So if you're assigning, if they're getting first, second, and third place, then order matters. You can't, you'd want first place, obviously. If you're just making a committee and you're not doing like a president, a vice president, or anything, then order doesn't matter. But in this case, anytime you assign places or positions, like where you've got, presidents over the vice president and so forth, that is order matters. So it is a permutation. So you can do this on the calculator. That's one way, or you can, so if you've got first, second, and third, 28 people can get first. But somebody gets first, and they're not going to also get second, so only 27 people could get second. And somebody's got first and second, so they can't get third, so only 26 people could get third. So kind of like the idea of the garage code here. So that would give you, if you multiply 28 times 27 times 26, you get 19,656. So that's one way to do it. That's fine if you want to do it that way. The other way is to do it on the calculator. So to do it on the calculator, I'll show you on the calculator here, but you'll start with your number that you're picking from, or the number of participants in this race in this case. So you do 28. And then you do the NPR, and how many places are there? It's first, second, and third, so there's 3 places. And that will also give you the same answer, which I'll show you here. 19,656. So on the calculator, what you do is, get it up here. You type in your N first, so that's how many participants you have in this race, in this case. So you do 28, and then you go to math, go over to PRB for probability, choose NPR, because that's a permutation. If it's a combination, you choose NCR. And then the number of places you have is 3. If it was doing the top 5 places, you do 5, and so on and so forth. And you still get 19,656. So you get the same answer either way. So it's up to you, whichever way you want to do that. So for this last page here, suppose P of A is 0.29, P of B is 0.55, and P of A and B is 0.07. Are A and B mutually exclusive? So I talked about that on the contingency table just a little bit when we were doing the ORs. In order for something to be mutually exclusive or disjoint, that means they cannot have any overlap. That means the probability of A and B, or the probability of both of them, is 0. So in this case, it is not 0, so the answer is no. And the reason is the probability of P, A, and B is not equal to 0. So find the probability of find the probability of A or B. So remember, ORs you add. So you do the probability of A, which is 0.29, plus, no, we can't have that. Probability of B, which is 0.55. And you add and subtract, I forgot to say that, or add and subtract. So add and subtract probability of A plus probability of B, subtract the probability of A and B, which it tells you is 0.07. That gives you 0.77. Find the probability of A bar, which means the complement of A, so it's basically like the opposite of A. So if you take the probability of the complement of A and the probability of A, they have to add up to 1, because it's, like I said, it's basically, you can think about it as the opposite. So you do 1 minus the probability of A, which is 0.29, which is 0.71. So the probability of B's complement would be 1 minus 0.55. So if you take the probability of whatever you're talking about, so A and the probability of A's complement, then they have to add up to 1. You can't lay on the paper, Goofy. So suppose you have a bag containing 10 red beads, 6 white beads, 4 black beads, 7 yellow beads, and 3 pink beads. How many beads are in the bag? So if you add them all up, you'd get 30. Suppose you draw 2 beads out of the bag. Once the first bead has been drawn, you look at it, look at the color, and then set it to the side. You do not put it back into the bag, so this is a big key, whether or not you replace it or not. That's a big thing. Pay attention to that. Find the probability of drawing 2 red beads. So in this case, it doesn't say the word and, but if you're drawing 2 red, that means a red and a red. So the and is implied. So just make sure you think about what words you're using. If it's an or, it'll say or. But if it says 2 red beads, that means the probability of a red and a red. You can't have the pen. Go back to sleep, Sean. So for ands, you multiply. So the probability of a red and a red. So how many reds are in the bag? For the first draw, there's 10 out of 30 as your chances of getting the first red. And then remember this, you do not put it back into the bag, which means if you draw the first red out, you set it to the side. That means there's only 9 left in the bag. And you started with 30, you've taken 1 out, so there's only 29 in the bag now. So that's why this is important. Pay attention if you're putting it back or not. If you multiply these together and reduce, this says leave in reduced fraction form, you get 3 out of 29. And if to do reduced fraction, you type in 10 over 30 times, in parentheses, times 9 over 29, and then hit math, frac, so just do math, enter, it'll give you the reduced fraction. Suppose you draw 2 beads out of the bag. Once the first bead has been drawn, you look at the color and then place it back into the bag. Find the probability of drawing a red and a white bead. So in this case, it tells you the word and, so it's not just implied. So the probability of a red and white. And this time you put it back into the bag, which means you're always going to have 30. It's killing her not to get my ink pen. You're always going to have 30. So how many reds in the bag to start with? There are 10 out of 30. And the probability of getting a white on the second draw is multiplied by white. There are 6. Still 30 because you put it back in the bag. If you had assumed you got the red out on the first one and didn't replace it back in the bag, it would be 6 out of 29. But we've put it back in the bag. So if you do that one and reduce, you should get 1 out of 15. So like I said, type it on the calculator and then hit math, enter. It'll give you the fraction. Suppose you draw one bead out of the bag. Find the probability of drawing a pink or, here's the word or, white. So if it's a pink or a white, I'm going to do the probability of P, which isn't too good because that means probability, but since it's pink, I'll just do a P anyway. Pink or white. So add and subtract. So the probability that you get a pink, there are 3 pink beads, so you've got 3 out of 30, plus the probability that you get a white, there are 6 white beads out of 30, minus the probability you get both. Well, you can't, you're either pink or white, or you can't be both, so minus 0. Like I said, if you add and subtract, you won't ever forget. So this is 3/10. Suppose you draw 3 beads out of the bag. Once the bead has been drawn, you look at the color, then you set it to the side. So you do not put it back, so this is without replacement. Find the probability of drawing a red, followed by 2 pink beads. So again, this doesn't use the word and or. So the and is implied, because you're going to do the probability of drawing a red, followed by 2 pinks, which means it's the probability of drawing a red, and a pink, and a pink. So the and is implied, and this, you do not put it back. So to probability of getting a red on the first go, we've already done, it's 10 out of 30. Assuming you get a red and you set it to the side, you're going to draw another one and try to get pink. So pink, there are 3, and you have a red one out of the bag, so there are only 29 left in the bag. And then assuming you've gotten a red and you've gotten a pink, you're going to draw again and try to get another pink. So you've got a pink sitting out, so there's only 2 left in the bag now, and there's only 28 beads in the bag because you've taken away the red, this red one and this pink one. So you have to assume when you do these, I mean, if you pick out if you put your hand in the bag and draw one out and it's white, you just quit because you didn't get a red on the first go. But so to get these other answers here, to get these other numbers, you assume you get a red, means you draw again, you've got 3 out of 29 because you've got the red out. Assume you've got the red out and you've got a pink out, so then all that's left is 2 pink out of the 28 left. So multiply all that together, do math enter on your calculator, and you should get 1 out of 406. So the probability that you draw a red followed by 2 pinks is 1 out of 406 chance. So not too good. That'd be kind of hard to do. What are the odds in favor of drawing a red bead? So odds are a little different than probabilities, because what you do for odds, so in favor of, that means that goes first. So the odds in favor of drawing a red, how many red are there? So I always write this as a fraction before I write it as the ratio notation. So red, there are 10 out of how many beads, which generally is 30, that's the probability. But when you do odds, you put whatever you're talking about, if it's in favor of, that goes on top. So let me make an arrow here and put red. And then how many beads are left over and that are not red, basically. So not red. So like the complement of red, if there's 30 beads total, 10 are red, that means 20 are not red. That reduces to 1/2. So the odds in favor of drawing a red bead are 1:2. So I think it's simpler to write it as a fraction first and then switch it over to the colon ratio notation here. So just remember, if it says in favor of, then that goes on top of in the numerator of your fraction and first over here. If it says against, you'd flip it. You'd do not red and then red. On the bottom, yeah. And then what are the odds against drawing a white or a black bead? Well, white or black, how many do you have of those? You have 6 white and 4 black. So 6 plus 4 gives you 10. You can't be both, so you're one or the other. So it says against, though, this time. Against. What are the odds against drawing a white or black? So you flip it. So on the bottom is 10. This is white or black. So if you've got 10 that are white or black, how many are not white or black? So the complement, I'm just going to do not white or black, WRB. Then there's still 30 beads total, so, beads. Sometimes I do marbles, but 30 beads total, so not white or black would be 20 of them. So this reduces, don't just write a 2, write 2 over 1. So your odds against drawing a white or black would be 2 colon 1. So I do the fraction first, reduce, and then that way you can turn the reduced fraction into the odds with the colon. So just remember, if it's in favor of, that goes first. So you do whatever it's talking about first, and then not the the complement or whatever it asked you, or opposite, or just not red, or not pink or whatever. And then if it says odds against, then that goes in the bottom, and that goes second on the when you write the odds. So this should help you with the homework for this week. If you have any questions, please send me a message, let me know. And like I said, the PowerPoint is posted with definitions. I didn't make the video just because I don't want to just read definitions to you, because I think the PowerPoint is pretty self-explanatory, and so it goes along with this as well. So if you have any questions, please let me know.